Bensound.com. 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 Bensound.com.
You're listening to Electrician Live with your host, Paul Abernathy. Well, there's the alarm. Welcome, everybody, to Electrician Live. My name is Paul Abernathy, your host, as always, and welcome to the show, as we do every Saturday evening at 8 p.m. Central Standard Time. Tonight, we have a really special show tonight. We're going to talk with the folks from Siemens about some of their load centers. We're going to talk about their plug-hole neutrals, and we're going to talk about their SPDs. Now, on tonight's show, we have some special guests with us. Here in the studio, we have a gentleman who's been on our show before, a call-in, so he's with us tonight. But we also have some other special guests that are going to be on with us as well. So what I'm going to do is go on and get to those guests right now and look and see what we got going on. So as you can see who's with me today, this is Vince Della, and Vince is with us. Vince, say hello to everybody.
Hello, everybody.
So again, Vince, I could read this about you. So Vince is the Business Development Manager of Electrical Inspectors. Vince represents Siemens as a Business Development Manager of Electrical Inspectors. He is licensed as a Master Electrician in both Florida and Washington. Vince holds an Associates of Science degree in Electronic Engineering and Electrical Maintenance Technology from Penn Foster College. He serves the IAEI Florida chapter as their educational chairman and IAEI Southern section as their assistant secretary treasurer. Vince is a member of the NEC Code Making Panel 17, which I'm a member of as well, so he's going to be on there with me. He also serves as a technical committee member on NFPA 73, which is the electrical inspections of existing dwellings, and NFPA 99 for the healthcare facilities, and NFPA 1078 for electrical inspector professional qualifications. Vince, thanks for coming.
My pleasure. I appreciate the invitation, Paul.
And we're going to have thanks for coming, and we're going to have a great discussion today. We are going to get into some, I guess we've got some special guests with us, and let's go on and kind of talk about who they are. We have Ashley Bryant, and Ashley is the Senior Product Manager for the electronic circuit breakers, and she's with us today as we're going to talk about circuit breakers and load centers and some of the things that have changed at Siemens and some of their new designs. Ashley Bryant has held various positions at Siemens for over 19 years. She doesn't look a day over 20, so I don't know what that started. So For the last 9 years, she has represented Siemens in a role of Senior Product Manager of Electronic Circuit Breakers. Ashley holds a bachelor's degree in Biosystems Engineering from Clemson University. She also chairs the NEMA AFCI Promotional Task Force Group and the NEMA AFCI Interoperability Task Force Group. Wow. Okay, so Ashley's going to be with us tonight as well. And also with Ashley is also going to be Patrick Hearn. Now, Patrick is the program manager for the plug-on neutral. And his bio is Patrick began his career at Siemens in 2014 on the product selection team. From there, he moved into the role of Load Center product manager, where he guided the product line for 4 years. He then transitioned to his current role as a plug-on neutral program manager. Patrick holds a Bachelor's of Arts in Economics from Auburn University. And also tonight we have a presentation. We're going to be talking about SPDs, and we have Bernadette Long with us as well. And she's the Surge Protection Devices and Metering Products Manager. Now, Bernadette has been with Siemens for 2 years and in the industrial space for the past 8 years. She is the product manager for surge protection devices and single and multi-family metering products. Bernadette holds a bachelor's degree in finance and an MBA specializing in brand and product management. So I've got all of them here with me tonight. We've got some pre-recorded interviews that we did so we could kind of ask questions and find out more about the products. And of course, we got Vince with us again live where we need to do that. So Vince, I think without further ado, we can go on and get into the first part. And we're going to learn about load centers and what's new with Siemens. And we're going to learn about the plug-on neutrals. Okay, so we're going to get started into that. You ready?
I'm ready. Let's do it.
All right, let's do it. You're listening to Electrician Live with your host, Paul Abernathy. Well, hey, everybody. Welcome to another episode of Electrician Live. My name is Paul Abernathy, your host as always, and welcome to tonight's podcast. I'm excited because tonight I have some special guests with me. We have some visitors from Siemens, and they're going to talk to us tonight about their latest versions of their load centers as well as their plug-on neutral products. So with me tonight, I have Ashley Bryant, who is the Electronic Circuit Breaker Product Manager, and Patrick Hearn, who is the Plug-on Neutral Program Manager. Both of them are joining me tonight. Guys, say hello to our fans.
Hello. Thanks for having us, Paul.
Hey, Paul. Thank you for having us.
Excellent. Thank y'all for coming. All right, I'm excited. I'm into this stuff, into this technology. I'm a geek. Everybody knows electrical geek. So I'm a fan of Siemens products, so I'm excited to hear about what Siemens has going on.
Absolutely. We're excited to talk to you about the latest innovation in our Resi portfolio.
Awesome. So, again, we're going to look at this new technology, this advancement y'all have, new versions, but tell me, as a person that comes from the industry, which is dealing in a lot of technological advancements and products in electrical. I used to work for NEMA. So tell me, it takes a lot to come out with new products. It takes a lot of talent to do this. So tell me, what is your thought process when you consider a design or an advancement of a product or development of something? What is the process that Siemens and your groups go through to do this?
Yeah, there really is a lot to it, especially when you're considering such a large change to an entire product line that is really key to the residential portfolio. But the thought process on this one, it really started with the installer. We knew we wanted to do something, and we knew we needed to make a change, but we wanted installers to determine exactly what that change would be. We knew it'd take a little bit longer to do it that way, but we wanted the feedback of the people who are using these products every day. So a little over 2 years ago now, Ashley and I and a few other people hit the road to do focus groups, and we just went to several cities across the country, tried to hit different city types, everywhere from Boston to Asheville, and then the setup you see here in the picture is actually one in Atlanta. So we had these prep load centers that you see on these rolling walls that we would come in, and we tried to get 20 installers in each city to come in and wire them up, give us their feedback, the good, the bad, and the ugly. You know, what was it like to interact with the panel, what could be improved upon, and we really learned a ton in these focus groups. And if you can see in the picture there, some of them have a C above them, and in the distance you probably can't make it out, but some of those have a D above them. We actually took 4 different prototypes out that we wanted to get feedback on. And so we traveled around, we brought all that feedback from across the country, and ultimately the final product was decided upon by installers. So we can say what we have in the field today was determined by people who are actually using it day in and day out.
So they were able to put their hands on it. So you have input from actual electricians working in and day out, working with it. So you can take all that feedback together kind of and put it together in the advancement of the products. That's awesome.
Yep.
Awesome. So, and you know, and the other thing I guess is that you learn what are good, what's bad, what stuff you throw out. All that stuff comes out of these groups. So.
Yeah, I mean, and honestly, we went in thinking that installers were going to say one thing, and there were things that we learned that we were surprised by. We even, you know, in the picture there, you can see we provided a few tools that we could easily carry around from place to place, but we encouraged them to bring their own tools so we could learn what tools are installers actually using when they're in here working in these things. So we could consider all of that when we were looking at our design.
Oh, that is awesome. So again, I see here when I look at Siemens, I see the concept of simple, spacious, and secure. So kind of walk me through this thought process.
Yeah, so this really comes from the focus groups. These were the things that the installers told us that they wanted in a load center. So simple, what we're talking about there is really just ease of installation. And then of course spaciousness, and security was actually huge. And what I'm talking about is the security of that new plug-on neutral clip. And that new connection, how it connects, and how they can be confident in it. And so in the next few slides, we're going to kind of go over these in detail and how these new products accomplish all 3 of them.
Excellent. Okay. So we have the Legacy series, and we have your new plug-on neutral series here, the 2 panel boards side by side. Kind of walk us through this.
Yeah, what I'm showing here, I've got some of the features that are listed out that we offer in our main line of load centers. And along with this idea of ease of installation and being a simple concept behind the load center is consistency with what's already out in the field. You know, how many changes am I going to have to make to adopt your new product? And really, if you weren't looking for it, seeing the 2 of these side by side, you may miss that they're even different. Right?
Yeah.
If you go ahead and click, you'll see that integrated neutral bus that's just added right in there, right underneath those hook rails. Again, if you weren't looking for it, you might not even see that it was there.
So you're carrying over all the legacy products, the legacy features, I guess, that are very popular and trusted and tested and true, and you're just enhancing it. You're carrying them over to the new series, but you're integrating the neutral bus.
Yeah, it was an important concept in the design that we didn't take away features that installers said that they loved or that they wanted to keep. So we tried to carry over as much of that as we could.
All right, so let's talk a little bit more about this plug-on neutral here. So tell me about it. I'm seeing that plug-on neutrals telling me I'm not going to have pigtails, and tell me a little bit more about it. I see here it installs like any other breaker.
Yeah, so when we were looking at the different designs, one of the key feedbacks was don't add any steps, right? Because each step that you add is multiplied over each breaker that we install, over every load center that we install, and that time factor adds up quick. So the more you can take away in the install process, the better. So now without that pigtail and being able to just plug that breaker straight on, it really plugs on just like any other breaker. The way that, and we'll dive a little deeper into the design here in a minute, but it's really cool how you can plug on a thermal mag and then plug on the electronic breaker, the plug-on breaker right next to it, and they use the exact same hand motion, exact same method, so you're not having to learn any new techniques. There's no added steps. We're actually taking steps away by doing it.
So the same secure hook rail, everything's the same. It's not creating additional steps, and you're able to do it without the big tail. So this is the simplistic portion of it. It's simply grab and go, just like an electrician would normally do with a standard circuit breaker. But now let's talk about the spacious, okay? Because I can see a before and an after here, and as an electrician, space is very limited in these panels, and really see night and day from the left side to the right, definitely.
Yeah, and again, space was just key. The obvious reason that you need space is just room to work, right? So with our design, you're not having to try to thread a wire in with just a couple of fingers, but you can get most, if not all of your hand down into the wireway to be able to get in there and work. And like you said, space is valuable. With load centers, we're restricted by that distance between the studs. So every eighth of an inch really becomes incredibly valuable. And with our small breaker footprint, we're able to offer over 4 inches of that wire bending space. Think about the situation where, for whatever reason, you weren't able to invert the panel, but you still have to bottom feed. So you have to pull those phase conductors from the bottom and loop them and run them through that wireway. This design gives you lots of room to be able to do that and it not to get in the way of the branch wires. And one of the things talked about in the focus groups that we learned was they were excited about when they had to go back into this panel. So if there was a change order, they've already wired the panel up, they've gotten off the job, but somebody decides they need to add an additional circuit and they have to come back, and maybe it's not even coming back to their panel, but somebody else has wired it up and they're having to open it up. Just how much easier it is to go into this panel where they can have complete access to that neutral bar, be able to see all the connections and where they're going. Just a nice clean look. And plus, this was actually interesting. Several of them commented on the fact that inspectors are really going to like this panel just because it's going to be that much easier for them to take the cover off and be able to take a quick, easy look. Absolutely.
The sheer ability to be able to see what's in there. I mean, one of the things, if you look at the example on the left, I mean, if I'm going to terminate, some neutral grounded conductors on the bus and I can't even hardly get to it, there's a greater chance that somebody's going to double lug and things like that we don't want them to do within the NEC. So on the right, I've got ease of getting to the bus. I can see it. Inspectors can look at it and be able to tell what's going on. I think it's great. So obviously all of these things appear obvious, but again, it's night and day when you see to the left and to the right. And I do like the smaller footprint of the breaker itself. Sometimes those larger breakers take up a huge footprint, but it's nice and tidy in here. So I do like that, definitely. So with that said, we're not losing the hook rail, right? So tell me, this is a tried and true connection mechanism that y'all have utilized for years, and it's tried and true. We're not losing that.
Yeah, and this was key feedback that we received. Just any concept that didn't include the hook rail just was immediately dismissed, right? We wanted to include that hook rail. It gives that nice secure fit. You don't have to worry about the breaker sliding around and any of the connections being loose, right? It pops in and you know that breaker's in place once it's popped down using that hook rail.
Okay, so it begs me to ask now, we're going from legacy to new panel board. We're going with the new technology here, and you're talking about this plug-on neutral. How does this connection get made? How does that neutral connecting to the plug-on neutral? I see in this graphic we have that integrated neutral bus that's there. Kind of explain that a little bit.
Yeah, so I'll chime in. The clip that we used on the line side of the breaker that we've used for over 40 years, we've actually used that same exact clip on the neutral connection side now. So the clip that has been tried and tested for many, many years is on the neutral side, and between the hook rail and the tested clip, you've got a secure connection on that neutral bar.
Oh, excellent. So it basically is the same gapping, the same as you would do on the line. It's utilizing the same thing for the neutral. It's clicking right on there and making that same positive connection.
exactly. Yeah, and if you click on the next slide, we've kind of zoomed in a little bit for you so you can see a close-up of the line side clip and the neutral clip.
Oh, excellent. So it basically looks, the clips look identical. So you're saying that's that tried and true clip method that's going to make that nice positive contact both on the line as well as in the neutral, all integrated into this one breaker.
Yes, sir.
Yeah, so it gives us the ability, if people push back and say we're not confident in moving away from a bolted connection where we can see that wire connected down, we can say, yeah, but if you're confident in that line side connection, you can be confident in our neutral connection because that's a tried and tested technology that's been out there, and just how we know how thick to make that phase bus, we know how thick to make that neutral bus.
Absolutely. I've been doing electrical work for over 30 years, and I can tell you right now, and you look at the pictures in this way, and we're so relying on the line clip and how it makes such good connection, and I can see here that utilizing that same concept to do the neutral seems to be going to work perfectly. So, all right. So again, we see all these new features. We know that the legacy panels are there. We see all these new things, this new clip-on neutrals, this new integrated neutral bus. So of the features, again, most of these existing features will obviously carry over, but I understand there's some finer points in some of the new features that we want to talk about. I noticed here in this slide, and I got excited because not only we're talking about the plug-on neutral, a little more about the ground bar, but it's tie strap and interlock kits for generator applications new. So there's a bus plating. So y'all going to walk me through these changes here with each one of these new items?
Absolutely, yeah. First, we'll talk about the plug-on neutral breakers. We will be offering in our portfolio the combination type AFCI 1 and 2 pole breakers. We'll have the 1-pole dual function breaker, which is your combination type AFCI and GFCI in one device. And we will also be offering the 1-pole GFCI in a plug-on neutral circuit breaker.
All right. And so also for my listeners out there who are understanding AFCIs and GFCIs, they understand that the combinations are both series and parallel arc detection, and the dual function is GFCI and AFCI, which only been out a couple years, right? The dual function, but again, it's all going to be available in this new plug-on style. Awesome.
That's right. Yeah, the National Electric Code 2014 started requiring dual function breakers. It started requiring AFCI and GFCI on laundry areas and kitchens. So that's why we released a dual function circuit breaker. That breaker will cover both the AFCI and GFCI requirements in one device for those two areas.
Absolutely. So we got all our 210.12 and 210.8 things taken care of all in one device. That's what I'm talking about.
There you go.
All right. So now, what do we need to know? Are we losing anything? We've dealt with pigtails for years. Are we losing any of that? I noticed some bullet points here. Explain them to me a little bit.
Yeah. So we will not ever get rid of the pigtail breakers. Those pigtail breakers will always be used for legacy load center, retrofit, renovation type applications. So we will continue to provide our existing pigtail breakers. The plug-on neutral breakers are just in addition to our current portfolio. Also important to note, the pigtail breakers will fit in the new plug-on neutral load centers. So if you're in a pinch and all you've got is your pigtail breakers, you can absolutely use those in the new load centers, and you won't have any issues. Now, if you've only got the plug-on neutral breakers on hand, you will not be able to put those into the older legacy-style load centers. We've actually, for safety purposes, we've put a little rejection feature on those breakers so that they cannot fit into the older style load centers, because essentially what you're doing is you won't be able to execute the electronics in the breaker without having the pigtail to plug onto the neutral bar.
Gotcha.
So that's why the plug-on neutrals will not fit into the older style, but the pigtail breakers, the legacy breakers, will still fit into the older style and the newer style.
Awesome.
Plug-on
And like you
neutral
said,
listen.
and like you said, you got that rejection feature if somebody tries to do it, you know. And I did notice something, you know, and we were looking at the different graphics, and I guess if we pick it up on this next slide here, the AFCIs, the combination asset, looks a little different to me than what we're familiar. Obviously, we lost the pigtail, but I'm looking at the pictures here. Explain these changes to these breakers a little bit.
Yeah, you're right. We lost the neutral lug as well.
Oh.
So in the AFCI breakers only, we actually took off the neutral lug. And this was one of the things, back to the focus groups that Patrick was talking about, this was one of the things that they were most excited about, because we were a little bit worried at first, because it will require, you know, a different wiring method than than what you're used to for electronic circuit breakers. However, the electricians, the installers said, no, this is exactly how we've always wired the thermomagnetic breakers. So this is awesome. So the AFCI breakers only will have only a load lug. And so you can wire all your grounds to your ground bar, you can wire all your neutrals to the neutral bar, and then all you'll need to do is run that one hot wire from your circuit into the breaker, and you're good to go.
So it's just like what we used to do before we had AFCIs, right?
That's right.
Yeah. So.
Yeah, so the dual function breaker and the GFCI breaker, we've still got the differential in there because you're trying to detect the ground fault. So the dual function and GFCI breakers will still have two lugs. You'll need to keep those circuits together and run the hot and the neutral into the breaker. But for the AFCI, and thank you for popping that the line diagram up. The AFCI, you can just run your hot to the breaker and your neutral to the neutral bar.
Nice, I see that. And then, of course, the dual function, again, we need the differential between the hot and the neutrals if there's any, you know, leakage current. So still going to wire that as normal. You're still not going to need the pigtail. I mean, it's going to click right onto that feature and take care of that, but you're still going to run your circuit to the breaker and just don't have to worry
That's
about
right.
the pigtails.
Yeah, exactly.
All right. So I'm excited. So I'm understanding how these new breakers, I'm seeing a lot of labor being saved here. I'm seeing a lot of errors being corrected in installation practices because of all this, kind of keeping it very simple. So let's talk about your SN series and PN series and panels and what you're doing here, because I know you made some changes here.
Yeah, I really wanted to hit the change that's going on in the ground bars. So since 2011, our main line of load centers has been broken into the S series and the P series. And that S series traditionally has not come with a factory installed ground bar. And that was really done for flexibility. So if an installer wanted two small bars, one large bar, if they wanted them mounted lower, whatever they wanted, they could do it. But again, I know we keep talking about the focus groups, but this is all coming from the people who are actually using it. They said that having that ground bar factory installed is more important than that flexibility. Plus, if you have it installed, you still have the flexibility to add another one or to move that ground bar around as they need to. But more times than not, they find themselves going out to a job and not having everything they need once they get there, right? They may have forgotten to pick those up as well. So this is one less thing they have to remember, because moving forward, all of the SN series panels, main lug and main breaker, are going to have a single factory installed ground bar. Now the P series has always had two, and that's going to continue into the PN series. It'll have two factory installed ground bars. And both the one in the SN series and the two in the PN will have that 2-aught lug on it as well. Again, that's just coming from feedback on really how many people are pulling SER cable that's got that larger ground in it. So they need to land that. Yep.
So I'm thinking me as electrician, either way, I don't have to worry about if I'm going with the Siemens here. I don't have to worry about, oops, I'm on the job site and I forgot my ground bar. I got to head back to supply house. Y'all are going to put it in the SN, and we've got the same 2 in the PN that we've always had. And it just seems to me that this was a good move to put it in for as an installer. You're basically, you're giving me an extra, you're giving me a ground bar. Okay.
Yep.
Excellent. So absolutely. So let's see here. So again, I have installed quite a few generators in my time, so I'm very familiar with what interlocks are and those type of things, but I see that you have a new interlock kit. So explain to me a little bit about this.
Yeah, so for the most part, we were talking about the consistency in design. All of our accessories are going to carry over, but I wanted to make sure everyone was aware that the exception to that is going to be the interlock kits. Because of the plug-on straps and some changes that were made up at the top of the base pan, the spacing has changed between that main breaker and the branch. So anytime you've got that main breaker that's bust in and you need an interlock kit, it's actually going to be a new kit. We're obviously going to continue to offer the old because there's plenty of install base out there that may want to install a generator, so those are still going to be around, but we are creating the 2 new kits that are going to be used on the new load centers.
Excellent. So they don't have to worry. There's the new units, new systems, new plug-on neutral panels. They're going to be able to get an interlock kit. There you go. And then of course they got the legacy for all the existing stuff, so that's got them covered. All right. Now, I noticed this as well. You're talking about lug kits, a new add-a-lug kit. Explain this to me. This is something new for this series of guests. So let me know about this.
Yeah, so this is actually a new accessory on top of what we already offer, and it's one that, because it is new, I think it's going to take a little bit of time for people to learn about it, but I think it's really going to be well received once people realize the benefits of it. And basically, if you can see that the arrows pointing to the left neutral there that doesn't have a larger lug on it right now, in the wiring schematic there, what we're calling the N2 position, you're able to put an identical lug to that one that's in the N1 that's over there on the right side over on the left side. So although the add-a-lug kits that we have today will still work, the ones that go over the neutral bar, but those really get in the way. They consume neutral space, the terminals that you need. Now you're going to be able to put one up in that top position and straight in wire, so you're not having to try to bend it in that small little area there, but you've got more room to maneuver it and work.
Yeah, you don't know how many times that I would do a remote distribution panel and I need a bigger lug to be able to go out to a downstream panel, and the add-on kits that take up lugs, you might not have enough lugs, and so the thought of me being able to just simply add a lug that's equivalent to what N1 would be over on N2, as in your schematic here, is huge for me. It gives me the flexibility if I need to bring a larger conductor to this bus. So that is awesome. So excited about that. But now I get to what I need to know. You mentioned tie strap a little while ago, and I'm familiar with the legacy, the wire that kind of comes across the front. So tell me what's changed with your tie strap.
Yeah, so for us to get those new neutral bars in there for the plug-on connection, we had to figure out a way to connect everything, right? So the 2 existing neutral bars and the 2 new ones. And the best way to do that was to actually run that tie strap behind the baseband. Of course, it's insulated from the back of the enclosure, but now it's running behind, which is a change for us. We've always had the tie strap on the front, and it's always been removable, but that's going to change, and in the future, in the plug-on neutral, you're not going to be able to have that option. So there is a little bit of loss of functionality for the people who are used to using our split ground models that have the neutral on one side and the ground on the other. But the fact that we're offering that ground bar in all panels now, you've still got the same functionality today as you had yesterday.
Well, I know that the one thing that some inspectors will say, or some electricians might say, is how do we know and how can we be confident that that connection between these 2 buses are there? So I noticed that in the blue here, is this a way to assure the inspector that connection? So how can we assure them this connection is solid between these 2 buses?
Yeah, so that little blue circle that you see there, we've left a little window that actually looks through the baseband so that you can see that tie strap running back behind there. I mean, but you would most likely be able to tell anyways, and the connections would be really loose and that sort of thing. But because it was a change for us, we wanted to leave that so that there was some way to confirm that tie strap's back there.
Excellent. All right. So next we take to that bus plating. Now I see CU on here. It doesn't look like copper, but I see the CU. So explain this to me, what we're doing with this and what was the thought process behind this?
Yeah, that's absolutely right. So in our copper units, anything 150 amps and above, we're actually going to be tin plating that copper. And to your point, it looks like aluminum. And during my time as product manager for Loadcenters, we had some three-phase units that were the same way. They had the tin plate, but they didn't have the CU stamp. So this was a big request at the time because I would get calls and people would think, oh, you actually sent us aluminum. We're not sure that this is copper. And to confirm it, they would end up scratching through that tin plating, which we absolutely don't want them to do. So when we were looking at the design and everything that we could add here, we decided to put these CU stamps so you would know when that's the tin plated copper. So 125 and 100 amp units, they're still going to be bare copper. 150 amp and above is going to have the tin plated on it.
So they don't have to scratch it, don't have to damage it. They can look at it. It's right there stamped on the product now. So stop all those people
stamps,
from doing that.
Those stamps actually go the length of the bus, so they're right there next to the stab on the opposite bus, all the way up and down. So it's not like it's going to be hard to find. You'll see them.
Oh, awesome. So let's kind of recap. We know that we're dealing with the simple, spacious, and secure, but kind of give us and all of our listeners a recap of what we're talking about here.
Yeah, so that's simple, the ease of installation, right? That quick breaker installation, the fact that our AFCIs were able to pull that neutral lug off, just making the install process even easier, going back to how you install a thermal mag, and then the consistency from the legacy to the new, and just carrying over all of those features, and having the same great benefits of the legacy now with the new plug-on feature.
And the spacious.
Yeah, and we talked about just the many benefits of having all of that space, and it's really allotted because of our small electronic breaker footprint, right? That gives us over 4 inches of wire bending space, gives you complete access to that neutral bar, and we talked about the cleaner panel, being able to go back in, and just all the benefits of the spacious panel.
As an electrician, I'm just thinking of all that cross-sectional area that I'm gaining now. All that space that I need in my design is what I'm thinking about. So, and of course, as a wire and cable guy myself, I'm thinking about the ability to dissipate heat a lot better with all that open free space. That's the things that come to my mind. So, and then talk about the secure.
Yeah, and again, this was the biggest hesitation that we had as we went out to talk to installers about a plug-on connection. They wanted to be confident in that neutral connection. And this is where we can go out and say that same technology that we're using on the line side, we're using on that neutral clip. So you can be confident in that connection. We've still got the sturdy hook rail, so you've got that nice, snug, secure fit.
Actually, so we're moving forward. So Ashley, promise me, pigtail breakers not going away, not being discontinued. We're moving forward, but we're keeping the legacy.
That's right. We are not getting rid of the pigtail breakers.
Right. So you're going to have options as you move forward. And I guess lastly to y'all is all of the accessories that you have today will work in your new load center, except for the fact that you came out with a new interlock kit, right?
That's right. So any of your main breaker kits, your feed-through lug kits, your breaker accessories, so your handle ties, those sort of things, all still good to go. The one exception to that is the interlock kits, and that's because of that main breaker to branch breaker spacing. Yep.
Well, that's awesome. Hey, guys, I want to thank y'all for coming on the show tonight and telling us about the Siemens products. I'm excited for them. I'm excited for y'all. Obviously, the two teams worked great together to come out with these these enhancements for your load centers. And again, Ashley, Patrick, I want to thank y'all for coming tonight to the show. And it was a pure pleasure to be able to work with you and bring this to our listeners.
Absolutely. Thank you for having us, Paul.
Yeah, thank you, Paul. We appreciate it.
Absolutely. Well, thank y'all. All right. That was awesome. Ashley and Patrick talking about load centers and the new plug-on neutrals for them. And again, I was impressed by both of them with their knowledge of their products and things like that. So Vince, you have anything? Again, for everybody, this is Vince Della Croce, and he's with us from Siemens as well, live in the studio. So
Live and in person.
live and in person.
So yeah, again, a thank you to Ashley and Patrick for taking time out to record that material. Obviously, I think everyone would agree they were down in the weeds on the design and implementation of the plug-on neutral load center. But also, I want to recognize our product people, our engineers, and our R&D people back in the lab who really, put their nose to the grindstone and came up with a really, really sleek design for the plug-on neutral load center and the associated breakers. So, a lot of time, a lot of effort, a lot of hard work put in by our folks in the Norcross area to make that happen.
All right, excellent. So now we're going to transition. Of course, we're going to have a little discussion. So everybody that's on the stream or those that are listening over on the podcast, again, we have a lot of people that listen to our podcasts. Generally, Electrician Live started out as a podcast, and we had the video that runs simulcast with it. But it's the podcast folks that they're painting you a picture. Come on over to the video stream when you get a chance and start watching the video a little bit as well. But I appreciate all the podcasters and all the video folks out there. So now we're going to meet Bernadette Long and talk a little bit about surge protective devices. Okay, so let's go on and get with Bernadette. All right, well, I'm excited tonight. We have another special guest with us from Siemens, and we're going to talk about their residential surge protecting devices. And our guest is Bernadette Long, and Bernadette, again, comes to us from Siemens, and we're going to learn all about these products. So Bernadette, thank you for joining me tonight on Electrician Live. Tell us a little bit about yourself and what you do for Siemens.
Sure, of course. So I've been with Siemens for about 2 years, and I've been working in the industrial space for about 8 years. And at Siemens, I'm the product manager for their surge protection devices and their PowerMod and Talon meter mounting equipment.
Okay. So we're going to learn everything that we need to know about surge protection devices tonight, at least from the Siemens side, right?
Correct. And more in the residential space too.
Residential. Absolutely. Okay. Well, let's kind of start it here. I kind of got it on the screen. I'm leading into it. So tell us what we got here and give us some good information. I know I'm a code guy, so I know that 242 is a new article in the 2020 National Electrical Code for overvoltage. So it moved everything from 280 and 285 down here into 242. So you're going to give me some good info here.
Exactly. So, surge protection is important to have in general. And for the most part, people have been using it in a lot of commercial applications for, high rises and things like that. But these recent code changes have now required surge protection in all dwellings. So now it's not optional anymore. It's now required for all dwellings. And so now we had to kind of expand our surge offering to welcome in this new audience that will now be looking for surge protection products.
Absolutely. So I see here on the screen, we got a bunch of different choices here. So
correct. Yes, there's a bunch of different items, and I will actually be going into detail about each of those throughout the presentation.
Okay. All right. So now, as I teach code all the time to people, this requirement is going to be limited to type 1 and type 2. So yes. This is type 1 typically on the line side or supply side of the overcurrent protected device, and of course type 2 on load side.
Yeah, so type 1, it can do both load and line, and then type 2 is just the load side only. So while we have both options, just know that type 1 can be used in both type 1 and 2 applications, but type 2 can only be used in those type 2 applications. It's not interchangeable.
Okay. So tell us a little bit about these circuit breakers and surge protection. It's plug-in style, plugs right in?
Yeah, so this is actually a circuit breaker and surge protector in one unit. And so it plugs into a load center and it functions as a circuit breaker and then also has the surge protection feature in it as well. And so as you can see from this image here, it's designed as it has 2 one-pole breakers in it, and then you can see kind of the green spaces in there that let you know that your home is being protected by the surge protector. And once that flips to red, that means that it has absorbed all of the surges that it can absorb and you need to replace it.
Okay.
And so that's kind of one of the indicators of that. And another indicator is actually the break could trip as well, letting you know that it needs to be changed. So if you don't happen to see the color change, your breaker will trip, and then you'll definitely know. You'll be able to go out to your box and see, yes, it's red now and I need to change it.
So it integrates, it still has the trip feature of a standard overcurrent protector device, just all incorporated into one component.
Exactly. And so as you can see here, we have 2 different options, a 15 amp and a 20 amp. Okay. And and it's a type 2 SPD. So, it's also a 40 kA surge current protection so that you can kind of get an idea of what type of protection you have. So that's kind of how much can this protector take before it needs to be replaced.
Yeah, I think a lot of people don't realize that surge can come 2 ways. It can come in from exterior sources or also be generated from interior sources. So
that's true.
So, surge protective device. I mean, I know that the code has been expanding in the last couple of years and really moving surge protection all over the place in the code, adding it. And we now pick up against the residential dwelling application. It just makes sense to me knowing what damage surges can do to electronics and components. And people forget that a lot of our sensitive electronic equipment in our houses can be really susceptible to surges that can cause them, like AFCIs, the GFCIs, the smoke alarms, things like that can all be susceptible to surge. So again, this kind of helps that avenue.
Right. And, additionally, all of our devices and electronics that we're starting to put in our homes are getting more intricate and more expensive. So one would want to protect that. Absolutely.
So I have the next item. I mean, I'm familiar with the First Surge and I always promote it all the time. I use it in a lot of the graphics I design. Tell me a little bit about it. And I noticed that it can be exterior or interior. Tell me a little bit about this product.
So this one, this is a First Surge is a brand that we have, and this is type 2. And so you'll see in the installation of this load center that it's separate from the bus, and it has to be wired externally to end up on that bus. And you'll see that there's a breaker that it has to wire into to provide that protection. So just the difference between the one we just talked about where it's actually directly on it. This one you'll see it can be placed anywhere in the box. It just has to be wired to the bus separately. And then it's just one of those, you want to keep that wire as short as possible so that your protection is as quick as it can be.
Absolutely. And I noticed that the surge current protection gets a lot higher on this, 60 kA, 100,000 kA, and 140,000 kA. So you have multiple options here.
Exactly. So it's one of those, depending on your area, some areas are more susceptible to thunderstorms and things like that. And so depending on your area may dictate what you need here. So we have the 3 different options here. And this one to let you know whether or not you need to replace it. In addition to a visual indicator going from green to red, it also has an audible alarm that'll let you know it's ready to be replaced.
I like that. I like that audible, be able to let you know people are out of sight, out of mind. They could be going in and out of their garage or wherever this is at, and they just don't think about it. And that audible alarm will let them know, hey, come look at me, pay attention.
Right, and oftentimes they may not even know it's there because the builder put it there, and so the homeowner doesn't
Right,
even
they
know they're
call
supposed
me
to
as an
check.
electrician. They hear something alarm going off, and they panic, and I come out there and I tell them it's a good thing. It's your first surge, and it's time to replace. It did its job.
Yep,
It did what it's supposed to do.
exactly. And oh, by the way, I have some in my truck.
I've got one right here, ready to replace it. Definitely. Okay, now tell us a little bit about this. Now I noticed that you have, it says new available now. It says Bolt Shield SPD family. Tell me a little bit about this.
Yeah, so this is our new family of SPDs. We launched these this past spring, and this is a family where the design of it has the same form factor as a circuit breaker. It's just that it's only a surge protected device. So
Okay.
and it comes in two types. We have the QSPD, which is more for residential applications, where it plugs right into the load center in the space of a circuit breaker that a circuit breaker would be. And so this
Okay.
one it plugs right on there. And then we have the BSPD, which is leaning towards more commercial, where it bolts on to lighting panel, panel board, switchboard, whatever your application may be in that more commercial space.
Oh, so I mean, you got the whole gamut here. We've got the circuit breaker design style that you can feed the
Mm-hmm.
circuit right into it. You've got the external one with the surge first, and then we've got this design that just takes the place of a breaker and connects right into the panel and be able to protect it that way. So all different phases on that.
Exactly. And so we can actually go into some more details of the two pieces of this new family.
Okay, here we
So
go.
the
Let's
first
look at
one,
it.
yeah, so the first one, this is a QSPD where it plugs into the load center. As you can see in the image there, it's just hanging out amongst all of the other circuit breakers. And you see the pigtail there where it still has to
Mhm.
be wired in. And so this family is at 65 kA surge protection. And this also has an audible alarm and a visual indicator letting you know that it needs to be replaced. And
Okay.
this is a type 1 SPD. So
Okay.
now we're in the section where this can be used in both of the type 1 and type 2 applications. And this family has 4 options where I have listed there, 2 and 3 pole versions. And the differences there are essentially the different voltage needs that someone may
I see
need.
that.
And so
So
you can just kind
single phase,
of
three
compare.
phase, single phase, three phase
Mm-hmm.
options. Absolutely. And I
Exactly.
do notice you have it in your new sexy Snap-on neutral panel
Yes.
board. I see that. All right.
Exactly. So
Absolutely.
it's one of those, and so we were mentioning a little bit earlier about kind of the higher KA ratings,
Mm-hmm.
and what is good about this dual bolt shield line is that, let's say, so right now these are 65 KA for one SPD. Let's
Right.
say you have an application where you want to have more current protection. These can be combined, using multiple SPDs to get that additional protection that you need.
So kind of like an in series.
Exactly. You can basically you can put 2 of them together, and then that'll up your protection. And we have a table that details
Oh,
exactly how high it can go and what your coverage would be and all of that. But it's one of those you can put 2 or 3 or 4 depending on what you're trying to do and what type of current you trying to protect. And so it's just a matter of whatever you need, you just figure out 2 or 3, and then it'll
okay.
tell you all of the data points and voltage levels that it's covering.
Now, I can see that as being huge in the commercial area. Three phase
Mm-hmm.
applications are commercial. Residential, sometimes you're very limited, but commercial, I can see where the surge current could get really, really high, and you might need, and that's to be able to have that ability to do that is huge. That is.
And so
And
then to the bolt-on version, which is our BSPD, going into lighting panels and panel boards and such. This one we're a little higher at the 100 kA current protection, and it has the same audible and visual indicator as the QSPD, and it's also type 1. And this also can do the using multiple SPDs to get the higher current protection. And so this has a few more options, as you can see, of the 2 and 3 pole versions, and it's expanded on the system voltage that you can use for these installations.
wow, that That's a broad range of
Exactly.
products. Broad range of product to be able to put them together like that.
So you should be able to find what you're looking for, and whether you need 1, 2, or 3 put together. You should be able to find the app. You should be able. We should have a solution for your application.
Wow, Bernadette, that's a lot of information. The SPDs, they're all available now. The consumer can get these now, and they work in the new load centers you've got and all of your legacy load centers. And so that's awesome. Awesome to be able to offer that type of offering. Again, surge protection is expanding, and it's a very critical need. And it's awesome to see that Siemens had these products available to be able to bring that to the table.
Absolutely, and all of these states are going to start adopting the new NEC 2020, and so as they adopt, we'll have the products ready for them to order. Awesome.
Well, Bernadette, I want to thank you for taking the time to be with us today and participate in Electrician Live. Again, we wish Siemens the best in all of these new product offerings, and to be able to offer them to all of our listeners out there. We have electricians that listen all over the country, so I think they'll be excited to get their hands on it. So Bernadette, thank you for joining me today.
It was my pleasure. Thank you.
Thank you. All right. Well, again, Vince, we got to look at SPDs, and Bernadette did a great job.
Yeah, big thank you to Bernadette for the time again to give us some background information and product specific information on the SPDs.
The whole team at Siemens seemed like they all work really well together.
Yeah, we got a great group of folks in Norcross, which is basically the headquarters for our electrical products. All working together. Like I said before, our R&D people are there. We have engineering folks there. Most of our product managers are there. Working diligently, trying to support our customers and support industry, especially when we roll into a significant change, which is what we're dealing with SPDs. We really had some big expansion inside the 2020 concerning SPDs.
And we're going to look at that. So again, we had some knowledgeable people that came to us, Ashley, Patrick, and Bernadette, talking about the different products. Again, we're going to dig a little bit talking about the codes and associated with some of these. And again, probably going to focus here in the SPD area a little bit in those aspects of it. Again, we will talk service applications. So what are we going to look at? Bernadette was talking about the dwelling application. So do we want to give that a look and kind of dig a little deeper in that application for these dwelling units and SPDs?
Yeah, we probably should look at the information that was added in the 2020 23067, which Bernadette alluded to. So everybody's familiar with that if you're not already.
Okay. So we're kind of here, and I will go on and move this a little bit to the left so that we can get a little bit extra here, if it's possible. So let's see what we're talking about here. We've got
a new 23067.
23067 right here.
Right, specific to surge protection, and the A portion tells us that it's going to be specific for dwelling units only. So right now, as of the 2020, this is specific to services supplying dwelling units.
Okay.
So once we leave the dwelling unit occupancy, this requirement doesn't apply.
Okay, so we've got an A, B, C, D, and E. No, A, B, C, and D. And D is interesting because D is one of the rare times that it's saying if you replace a service, you're going to have to put these SPDs in.
Right. So yeah, if we jump to D, 23067D, and the code doesn't usually say basically when you touch it, bring it up to code. I mean, we have just a few handful of requirements when that comes into play for maybe arc fault protection of receptacles, tamper-resistant receptacles, just a handful, not very many, but this is one of the few spots that when we touch it, we're going to have to bring it up to comply with the code. So a service upgrade, a service change, where the service equipment was not previously protected by an SPD, when it is replaced now or upgraded, it will have to have surge protection at the end of that replacement.
and the types. We have, and I learned a lot with Bernadette in the fact that there were so many Type 1 SPDs that Siemens had to offer in their selection. But this rule is going to allow it to be Type 1 or Type 2 SPD.
Right, so we're working backwards here.
Yeah,
but
we're a
that's
little
fine.
backwards.
Keep everybody on their toes.
I was most enamored with the replacement requirements. Sorry, the code in me. So we started down and moved it backwards. So Type 1 and Type 2, like the ones we saw that Bernadette went over with us.
Right, so we have an allowance there. It can be either or, but to make that determination, we're going to have to know what a Type 1 is and what its parameters are compared to what a Type 2 is, and we'll have to go to, and we will be going to new Article 242 to drill down a little deeper to find out the difference between the Type 1s and Type 2s.
Okay. And then, of course, we have the location.
Right, so the B portion of this, 23067B, talks about the location, and it tells us that this SPD is going to have to be an integral part of the service equipment, or it shall be located immediately adjacent to the service equipment. So, but that really is not the end of it, because we do have the exception. And if you look at the exception, it's going to give us a little bit more breathing room on where to have this SPD protection. And it says in the exception that the SPD shall not be required to be located in the service equipment, as required in B, as required by the language we just read, if it's located at each next level distribution equipment downstream towards the load.
So if all I've got is a main service in this application, I got a remote distribution panel downstream, I could have it at the remote distribution panel.
You could.
It's an option.
As an option, yes.
I could have it in the panel at
Yes.
the service, and I could have it immediately adjacent.
Yeah, and I think installers and users now just have to keep an eye on that language that it's at each next level distribution equipment downstream. So multiple panel boards, multiple load centers downstream, each one would have to have SPD. So, what I see, my anticipation from industry and installers is wanting to install it once in one location, one piece of equipment, and being done with it instead of multiple pieces along the way. But the exception certainly gives us that option.
It's there, but probably the more prudent thing would be to put it at the service or immediately adjacent.
I would think that's the way installers are going to lean.
All right, let's dig a little deeper because we just wanted to look at that because that kind of was Bernadette was talking about for the dwelling applications.
Mm-hmm.
So we want to kind of get back to the presentation here and kind of look at some of these pieces that Vince has put together. So
yeah, so
before we do that, what do we got?
Before we do that, this is just a general heads up that I wanted to give to all your listeners and viewers that Siemens does have a document to support 2020 changes. And this is, to my knowledge, a first for Siemens. We've produced what we call an applications guide where our product managers and our codes and standards folks, including myself, have highlighted about 24 of what we consider quote-unquote significant changes in 2020.
Right.
So we provide the text, the code text, we provide the revised text. We also provide some commentary from our product managers and from our codes and standards team. And we also have some pictures and web links to product solutions to support industry and our customers of the changes.
Absolutely.
So easily shareable. This is a PDF document electronically shared, and we're happy to share that with industry, easily emailed, or find me on LinkedIn. It's accessible through my LinkedIn page, or people can hit me up, email me, or reach out to me through you, Paul, and we can get them this document. Not a problem at all.
Yeah, I know that our listeners, whether it's on the podcasts or the videos, they really like the NEC portions of it, and obviously being aware of the significant changes is important. Mm-hmm. And having this all together in one document available from Siemens is awesome too. And I see the table of contents hitting all the core hot topic items of the changes. So again, I'm good to see that is available. Again, you can reach out to me. I'll get you in touch with Vince, or you can reach out to Vince as well. And we'll have all the information, his contact, his email, also in the comments area of the post show. Okay, so you'll be able to have all that information and contact there as well. And if you're over on the podcast, again, you could go over to our YouTube channel. It's youtube.com/Master the EDC. You'll have content there, but we also will put all links as well in the bottom, as well as links to the Siemens website where you can get more information on all the products that we're talking about today. All right, Vince, let's kind of drill down through this here. So we want to look at a little history, do we not? So for some of you in the country, you might still be on this one. You might still be on 2011, but there has been a dramatic change over the last couple cycles.
Yes, I thought we'd just take just a minute to look at, just go back a couple of code cycles to see, where did we stand a few code cycles ago on SPD protection, and where do we stand now? So I only drifted back to the 11. I didn't go any further back than that. So if we flip through the 11, that's where we stood as far as SPD protection. Some class 1, division 1 and division 2, some class 2, division 1s and 2s, small wind electric systems in 694, and then COPS systems in 708. And that's pretty much where SPD protection landed, and it wasn't expanded until we moved to the 14, where Article 646 was added, and modular data centers were covered for SPDs, as well as industrial machinery in Article 670 required SPDs, 700 emergency systems, and also 810 radio and TV equipment. So all that was expanded for the 2014.
Now, I notice as this expansion, some of the areas are very critical areas, like COP systems, the reliability and all of the electronics and all the equipment that's connected into these different types of COP systems. And then, of course, again, emergency systems. That just makes sense. With all the electronic components, I can see where surge protective devices would emerge into Article 700 as well. And again, in 810, radio and TV equipment, all of that is susceptible to surge. Correct. So we have all that application I can see here where we would have that. And of course, again, not taking away the fact that 501, 502, you're dealing with areas that are hazardous classified locations. Obviously, limiting the surge is probably important.
Absolutely.
As well in those applications. Mm-hmm. So we go in further, again, 2017.
2017, we continue to see the slow expansion, and 17 expanded to Article 620, which is elevators and escalators and a few other items. Article 645, IT equipment, 675, irrigation machines, and 695, fire pumps. So quite a bit of expansion again in the 17. Right. And as we move to the 2020, what we just reviewed in 23067, the dwelling units. So, a slow, steady expansion. And, if you really drill down and look at the scope of the NEC in 90.2, it's the safeguarding of people and property from the hazards arising from the use of electricity. So SPDs, are focusing on the property aspect, and I think it was either Bernadette or Ashley and Patrick who touched on the concept, and you mentioned smoke alarms. Mm-hmm. So we have, when we look at dwelling units specifically, at this point in time, we have a lot of electronic equipment inside our dwellings that are providing life safety protection. Smoke alarms, like you mentioned, GFCI protection, AFCI protection, and there's a lot of electronics built into them, and we want them to work. Life safety devices, and a great way to protect them is with SPDs.
And of course, you're picking up on the fact that also, in addition to this, all of our electronics today that we have in our kitchens, our laundry, our washing machines now even talk to us. Our TVs have all these electronics. It doesn't take much of a surge to fry them, get quite costly. Again, so there's an element there that's going to protect other things in the house as well. And then again, surges can come from two ways. They can come external and internal. So again, you've got this protection that's required here in SPDs, and it's just expanding. And I'm sure we're liable to see maybe some expansion in the 2023 as well.
I wouldn't be surprised.
All right, let's dig a little bit again. It was 230.67. We kind of did look at it a little bit. We saw all of the offerings that are available from Siemens to be able to have these surge protected devices, and we kind of covered this. Mm-hmm. Dwelling units. Again, it can be a part of the service or immediately adjacent. Mm-hmm. We do have the exception. It does allow it downstream, but again, if you had another panel or another panel or another panel, then you're going to have to make sure that these are installed in each one of those panels. Now, if you had just one service panel and one remote distribution panel, then you would have it in one remote distribution panel. And I think the more practical way to do this is probably at the service. And again, somebody asked in our chat members that were chatting online with us on our YouTube stream, asked, is this whole house protection? This is whole house protection, okay, when it comes to surge. And then, of course, type 1 or type 2. Interesting, I learned from Bernadette, was that type 1 can go on the supply side as well as the load side.
That's correct.
And again, a lot of people tend to think that type 1 is only a line side application. And then, of course, you do type 2 on the load side. Now, type 2 does stay load side, but type 1 can go load or line.
Right.
So, again, good information there. And I think the reason I jumped to it earlier, it intrigued me so much, is, again, where the code starts to dabbling into this requirement for replacement, telling you have to replace something. And it's not the norm for the code, but over the last couple cycles, it's starting to tell you these different things about replacement. So, again, you do a service equipment replacement, SPDs, got to put them in.
Absolutely. If it wasn't there prior, when you're done, it should be in there. It's required to be in there by the code.
You were talking about definitions and understanding SPDs, because again, we could talk a lot about them, but if you don't have an understanding what they are, then you're going to be lost a little bit. Because again, a lot of this information is right here when it comes to the definition, Article 100. And when we start making references to the different types, how are you going to know what they are? Especially if you're selecting them. So kind of walk us through this, Vince, what we've got here.
Yeah, so I drifted back to Article 100 just to pick a few of these definitions off so everybody could see them. The definitions, definitions associated and the difference between surge arrestor and the surge protective device. I think in the NEC and industry now, I think we've drifted to SPD, the surge protective device, is the term for the most part that we're going to see. And type 2, type 1, type 2, type 3s are mentioned. So the type 1, the permanently connected SPD, intended for installation between the secondary of the service transformer and the line side of the service disconnect over current device. So this is going to be on the supply side of our service disconnect.
Okay, now we saw the type 1 could go on the load side.
Right, it can also go downstream, not an issue.
Okay, primarily type 1, but it's saying it's kind of one of those things where 1 is the hierarchy and it gets less. So if 1 is good on the line side, it should be good on the load side.
Right.
So
a little bit different for a type 2.
Type 2 different.
Permanently connected SPDs intended for installation on the load side of the service disconnect over the current device, including SPDs located at the branch panel. So typically, type 2 is going to be on the load side only. Then you're not going to see them on the line side, and most likely not listed to be on the line side either. Okay, and the type 3s are usually these point of utilization SPDs. These could be these plug relocatable power strip type
with the built-in
devices.
SPDs like we have on your localized, maybe on your computer or something like that. It's just another layer. I used to tell people that if you think of surge as like a lake and a dam, whereas the lake being the whole house protection and the ability to clamp and have potential for surge to get over the dam. If you have a real expensive, a lot of times we talk in 2-level protection. Okay, so, but again, he's talking whole house protection. But again, the type 3 would be something that you would put directly at like a computer or a flat screen TV or expensive flat screen. They're so cheap now, but again, to protect those.
Yeah, a layered type of approach of protection is most likely recommended by industry. But we have language in the NEC that deals with what is required. And we could certainly do, and we saw the information in the new information in 23067 that says in dwellings we could put 1 at the service and be done, and we meet the requirement, the code requirement. Could you install others downstream if you wanted to?
Sure.
Create this layered protection? Absolutely.
Yeah, there's the difference between what the code's requiring,
which is the minimum,
and what you want to add additional if you want. Okay, so for those out there that aren't familiar, you remember there was an Article 280 and there was a 285. And so they're gone in the 2020, and now it's been relocated to 242, which makes sense because it's right next to 240, which is overcurrent protective devices. It seems logical to move right into 242.
Mm-hmm. Yeah, so it's a merging of those two previous articles into the new 242 for over voltage protection. And we see the scope, general installation connection requirements for over voltage protection and the over voltage protection devices. And we also see that since there were two articles dealing with over 1,000 volts or under 1,000 volts, we still now have that as split as part 2 and part 3 in Article 242. So part 2, SPDs not more than 1,000 volts, and then part 3, surge arresters over 1,000 volts.
So when we're looking at part 2, which is the SPD, is probably what we're going to run in the most. But obviously, these are the ones that are going to encompass 23067. Right. So this is probably what you're going to run into the most. So it's 242.6 uses not permitted. An SPD device shall not be installed. Obviously, this is 1,000 volts or less. So you can't do it in circuits that are over 1,000 volts. That goes without saying. You want to pick up the...
Yeah, because we cover basically the over 1,000 volts in part 2 of this article. Parent 2 talks about ungrounded systems, impedance grounded systems, or corner grounded delta systems, unless specifically listed specifically for use on these systems. So when we do run into ungrounded systems, not overly popular, but they certainly are out there.
Still out there.
As well as impeded grounded systems, corner grounded delta systems, certainly out there. Mm-hmm. Not typically, I don't want to say it's not the norm, but those we'll usually see in commercial applications. Maybe not so much, I wouldn't think very often, certainly not a dwelling application.
No.
But so we just have to make sure that if we run into those applications and surge protection is going to be provided, we just have to make sure the listing of that SPD or multiple SPDs is specific for those type of systems.
Okay. And then Article 3 says where the rating of the SPD is less than the maximum continuous phase to ground voltage at a power frequency available at the point of application. Not even overly familiar with that at all. So it's just a statement.
Yeah, I guess could be unique installations out there concerning frequency. And if there is, we have some language there to give us some guidance on that.
242.8, an SPD shall be a listed device. Okay, so part of the listing.
Plain and simple. It's got to be listed.
And 242.10 is the SPD shall be marked with the short circuit current rating and shall not be installed at a point on the system where the available fault current is in excess of the rating. We do that as well for panels, overcurrent devices, different types of rating as well, equipment. So again, harmonizes with all that. This marking requirement shall not apply to receptacles. Okay, so we're basically the requirement for the marking of the SCCR is not applying to a receptacle application.
Correct.
So. All right, now 242.12, type 1 SPDs. See the graphic here on the right, again, courtesy of NEMA.
Right.
Okay, talk us through this a little bit. This is installation.
Right, so now we're going to get some specific installation requirements specific to a type 1 SPD. Okay, so the code breaks it up. We're going to get type 1 SPD information in .12, and most likely I think .13 or 14 has some type 2 requirements, but specifically for a type 1, they shall be permitted to be connected in accordance with one of the following. So on the supply side of the service disconnect, as permitted in 230.82.4, and if we went and looked at that 230.82.4,
that's listing all the things that we can have on the supply side of the service disconnection. Right. So that's a big list there. So this is just item 4 of that list. So okay. So
we install it that way, or we can do it as specified in 242.14, and we'll be looking at that language in
a minute.
And that 242.14 is really specific to a type 2. So since a type 1 can go on the supply side or the load side, as far as installation on the load side of the service disconnect, we can install it per the installation requirements for a type 2.
Now I notice here 242.12b at the service. So when I'm installing at the service, the SPD type 1, it shall be connected to one of the following. I got options here. I can connect it to the grounded service conductor, grounding electrode conductor, grounding electrode for the service, or the equipment ground terminal in the service equipment. So again, these are going to be mounted in the equipment. As you saw, Bernadette went over the different options as well. So, and they have a pigtail on them that you're going to have to make the connection. So you have options to where you can make that connection.
Yeah, and options are good. So installers, you have some wiggle room. It's not just one way, one size fits all. Certainly not. There's some options.
And that is actually a neat graphic. If you take time to look at the graphic, you see the type 1 encompasses downstream, and you look at the type 2 where it starts and shows it down, and that in the type 3 down local. So again, the point of view. So good little graphic that kind of depicts all of these.
Yeah, it's very helpful.
And here is the type 2. So 242.14a, service supplied building or structure shall be connected anywhere on the load side of the service disconnect overcurrent device, required in 230.91, which requires overcurrent protection and things like that. So unless installed in accordance with 230.82a, which is again one of those applications that allow you to put it on the supply side.
Right.
Now 242.14b, feeder supplied buildings or structures. So now we're going from one building to another building.
Mm-hmm.
It's a feeder. It's not dealing with the service. And it shall be connected at the building or structure anywhere on the load side of the first overcurrent device at the building or structure. Okay, so it'd be in the panel, adjacent to the panel.
Mm-hmm.
Okay, anywhere once you get down to that application and you're applying that protection for that feeder that's supplying the other building. And then 242.14c, separately derived systems, shall be connected on the load side of the first overcurrent device in a separately derived system. So if you have a separately derived system, you leave that and you go to the first enclosure with an overcurrent device. That's where you would install that's where you could install a type 2 SPD.
Yep.
Application. Now, this is probably very similar. Again, I'm a big fan of the surge, first surge. So this is an application, what we would constitute as immediately adjacent.
Yeah, absolutely.
Right? So a good example of something that would be immediately adjacent. So talk to us a little bit about the location and the routing. Really important about the routing. You don't need a bunch of loops when we're doing these type of things.
No, absolutely not. And we have information here we're going to look at, plus manufacturer's installation instructions that will also provide guidance. But as far as location in the .22 section, that tells us SPD shall be permitted to be located indoors or outdoors and shall be made inaccessible to unqualified persons unless listed for installation in accessible locations.
And I think most of yours are. I would say most of these are listed for installation in accessible, or basically they're right there by the panel and I can go right to them. They're not designed to be away so nobody can come in contact with them. I mean, these usually mount right by the panel, right?
Yeah. Ours are certainly easily mountable next to, adjacent to the service if you need to do that. Not an issue at all.
So I would say that these are probably listed for installations in accessible locations.
Yeah, and they're both. I think that first surge is a wet location type enclosure or a 3R type enclosure, but certainly no problem installing it indoors.
All right, absolutely.
So they shall be permitted. So we have a shall be permitted in the .22. When we look at the .24 section about the routing of the connections, that tells us the conductors used to connect the SPD
right here,
correct, to the line or bus and to ground shall not be any longer than necessary and avoid any unnecessary bends. So, if we use that first surge again for an example, there's a few feet of conductor that are left for the installer to get to a branch breaker,
right,
or get to the neutral bar, or get to the equipment ground bar.
Right.
I
just want to keep. We can do that for those, but when it comes to that ground, keep it short as possible.
Actually, all the conductors.
All the conductors as short as possible, even the ones that are going to the breaker.
Yes.
Short as possible.
And avoid any bends, unnecessary bends. So as straight and short as you can make them, the better. Put it that
So
way.
we don't want to take the excess and curl it up and put it in there because we just don't want to get rid of
Absolutely
it.
not. No.
I can tell you, surges do not like turning corners. Okay? And we want to make sure that the surge protective device functions as it's intended.
Right. And that,
So-
we have the language here in the .24 section. Look at the installation instructions from any SPD, and that application, most likely you're going to get the same guidance to keep the conductors as short as possible and as straight as possible.
So again, okay, so here you go. Here's the manufacturer's instructions for the first surge. It's a Type 2 SPD. It is suitable for use downstream of the service disconnect. So again, and we saw, I think we called a picture earlier where it was in the equipment,
Yes.
service equipment. We've seen a picture with it immediately adjacent, and obviously that would not prohibit it from being done the same way downstream
Right.
application. So kind of walk us through this, pre-planning your installation.
Yeah, so we try to provide some guidance to help, industry and installers, get these things in, give some clear guidance. And, we do, I'm not going to say we don't regurgitate some of the language that's in the NEC, but we do say meet all your national and local codes. And, sure, we have a lot of installers who tune into your broadcast. They're working all over the country, and I'm sure some of them are in municipalities or in cities or states or counties that have amendments to the NEC. And the amendments may be more stringent, hopefully not less stringent.
Right.
So if you have something specific to your local area associated with SPDs, make sure you know about them and install them accordingly. Confirm the system voltage to the SPD voltage. We don't want to have a higher system voltage than the SPD
Right.
is rated for.
Right.
Again, mount the SPD as close to the panel or equipment as possible and keep the leads short as possible. Ensure they're straight, including the neutral and the ground.
Include them all.
Include the phase conductors also. Use a breaker position that is close to the SPD and the panel's neutral and ground. So again, we want to keep these leads as short as possible.
So that's going to take a little management. You're going to have to know where you knock out, where you go in. You obviously want to do a little thought into this. You don't want to come into the right side and you're going to use the breaker on the left side of the panel. I mean, you got to think about it a little bit. It might cause you to do a little maneuvering around
Right.
in order to be able to do this, but you want to, again, keep them as short as possible, straight as possible. Try to reduce any bends.
Right. That's why we say pre-plan your installation. We recommend a 20 amp breaker to protect the first surge. Make sure the system is grounded per the NEC. So we drifted Article 250 for that, for all those grounding and bonding requirements, and clear any faults before energizing the SPD. Some type of ground fault, arc fault could affect that first surge on its initial installation, and I'm sure installers don't want to deal with a brand new piece of equipment
No.
that the magic smoke comes out,
Yeah.
and then it's back to the drawing board.
Yeah, and of course, when we install in systems, we're supposed to install electrical systems that are fault-free. So we want to make sure that we're installing, we're using bushings where we can, doing everything to protect the integrity of the system, the wires, all terminations, all equipment, doing everything, as we always say here, in accordance with the National Electrical Code, but then again, good workman practices and things like that.
Right. And the last bullet, just a heads up, not to high pot test any SPD. Most likely that high pot test is gonna damage the equipment, and
Why would you
nobody
do that?
wants to do that.
Why would somebody do that?
I don't
Just
know.
don't do that. That's the easiest way to do that is, should I high pot test an SPD? Just don't do that. Why would you do that? Great document from ESFI, again, talking about some of the actual factual informations about surges. And so, again, talking about the different devices. And again, this is a document, I guess you can get this from esfi.org. So
Yeah.
it's some good literature to things like, did you know? That type
Yeah,
of thing.
a lot of resources available for industry, installers, AHJs, both from ESFI. Manufacturers certainly have plenty of information.
Absolutely.
NEMA has a piece of their website dedicated to SPD information. So we can certainly supply information to installers or designers or AHJs who need that also. So there's no shortage of information to Google and go after, just like any other topic that people are interested in.
All right, so let's kind of go to me and Vince, if the machine will actually go to it. Oh, it is there, so we're already here. So we had some questions. People talked to us again. Vince, I think it's awesome that that you came in here with me tonight. Hopefully the listeners got something. Again, remember now, these videos as well as the podcast will be played over and over and over again in syndication through all of our platforms. All of our podcasts are available, and that's where most of our listeners are. That's Deezer. That's in iHeartRadio, that's in Spreaker, that's in Spotify, that's in Apple Podcasts, Google Podcasts, are all available as well there. Again, we also load these over on our YouTube channel for you to be able to do that. So I think that we had some kind of questions, and I will say that I actually was, as we were doing this, I was kind of answering questions as we were doing it, as you were asking the different questions. So I was able to add some additional information as well on that. But again, anything else you want to add, Vince, to the viewers out there or the listeners over on the podcast stream?
Well, we got to thank them for tuning in.
Oh, yeah.
And listening. Thank you again for the invitation here to world headquarters of Electrician Live here in the great state of Texas. It's great to be here. So we'll do it again, hopefully, in the future. But yeah, hopefully that's all good information for your viewers. A lot of change in the 2020 associated with SPD, so certainly we have to be aware of that. And any questions from the folks out there about the plug-on neutral, like I said, load center or breakers, or the SPDs, or you just have a code question in general, Siemens makes me available to support industry with information. So just like you do, Paul, you support industry quite well. I'm available. Siemens makes me available to support installers, our customers, or industry in general from a codes and standards perspective. So I like to say, use and abuse me.
There you go.
Reach out to me, and I'm more
we like
than
to hear
happy
that.
to support.
We like to hear that. Use and abuse. So reach out to Vince. And again, down in the comments areas, we're going to provide contact information as well to be able to reach out to Vince if you have any additional questions. So again, Vince, thanks for coming on.
My pleasure.
Thank you all for listening. If you have any other additional questions, please feel free to send them to me. Also, my email is info at masterthenec.com. And for those that like to hear it, Vince, you want to shoot your email out to them?
Maybe a little tough, but it's my first name, Vincent. You got to spell it all out, Vincent. And dot, my last name, Della, underscore, Croce at Siemens.com. Wait for Paul to post it.
We're going to put a link.
Yeah.
We're going to put a link to that.
Easier.
Okay. So we're going to put a link to that. So again, thanks, Vince, for coming on. Thank all of you. Sorry we ran a little over. But until next time, stay safe. God bless. You've been listening to Electrician Live with your host, Paul